Welcome to my channel. My name is Kidana Maram. In the previous tutorial, that is tutorial part 1, I have already shown you how to draw grid lines, how to define material property and section. Subscribe my channel to get more updated videos on structural design. Today, I will show you how to define stiffness modification factors for beam, slab, and wall section, and how to draw frame elements, that is column and beam, how to draw shear wall and wall section, how to draw slab, stair, ramp, and finally how to draw a reference plane and what is the functions of drawing a reference plane. Okay, let's start. uh, Go to define menu, section, frame section. So for beam 40 by 20, you have to go to modify. Okay, so modify or show modifier. Okay, click on modify or show modifier. So stiffness modification factor initialization box is coming. So for frame section or for beam 40 by 20, cross section area, make it as it is, that is 40 by 20. Shear area, for shear area and for moment of inertia, Ethiopian building code of standard or that of European norm says that reduce it by half. That is, for shear area, make it 0.5 and copy it, and you can use for shear area in 2 and 3 direction. This is in direction 2 and 3. So make it 0. Okay, make it paste here, and you can use this value for moment of inertia. Check Ethiopian building code of standard. And for torsional constant, use 10%. So make it 0.1. Okay. So mass and units, mass and weights of detection property is as it is. Make it as it is. So okay, you have to define similar for beam and column. Okay, modify. Okay, modifiers. So make it paste there. Make it paste there for torsional constant 0.1, and make it paste it for moment of inertia. Okay, make it paste it here also. Make it okay. So for similar for columns also. It's similar for show modifiers. Okay, shear area. Paste, make it half. Make it half. I use 10% for torsional constant. Okay, make it half for moment of inertia about 2 and about 3 respectively. Make it okay. Okay, for column 15 by 30. Okay, make it 0.1 for torsional constant. Make it okay. Okay, make it half. Sorry, why it's not copied? Okay, make it 0.5. Have to copy this value. Okay, the shear area. Okay, make it 0.5. Can copy this value and make it 10% for torsional constant and moment of inertia about axis 2. Make it half. Okay. This time we have to modify our stiffness modification factor for frame section, that is beam and column, and we have to go to slab sections. Make it okay. Okay, save, and have to go to slab sections. So for slab 150 mm, okay, modify. Okay, modifier currently it's default. Okay, modifier currently is default, so you have to modify it. So for slab, you have to use 0.5 for membrane action, and you have to use 0.1 or 10%. You have to reduce by 90%. That means for bending action, that is plan for bending action, and for membrane mean that for plan deformation only. So make it 0.5 or reduce by 50% for membrane or for deformations along the plan, for plan deformation. And for bending, that is for deflection, you have to use 0.1 or reduce your section by 90%. And for sure, make it 0 or make it as it is. It's not modified because slab is not exposed to shear. Make it okay. Okay, similar way for other slab sections. So make it 0.5 and copy. Okay, make it 0.1 and have to copy this value. Copy this value. Okay, sure. So make it okay. And for a staircase landing beam, make it similar. Okay, copy this value for membrane or for plane deformation and make it 0.1 for bending or for deflection value. So make it okay. Have to finish slab section. Go to well section. Okay, well section. Make it okay. So modify property. Have to get okay here. So for a well section, you have to use have Japan building code of standard recommended that to use or to reduce your bending and membrane actions by 50% and 50% also for shear wall, shear for shear along 1 and 3, 1, 2, 3. That is for a shear wall, because it acts as a frame section. It acts as a frame section, or it is a vertical. It is a vertical member. So you have to make 0.5, 0.5, 0.5. Okay. Okay. All the membrane bending and shear is reduced by 50%. Okay, this is good. This is because shear wall is a vertical member. Shear wall is a vertical member, and it's exposed to both shear bending and membrane effect. So deformation at membrane, that means. So make it okay. Okay. We have defined all the stiffness modification factors based on Euro norm or ETABS building code of standard. After this, we have to go to draw structural elements. So make it your plan basement. This is make it 3D and click on it and make it basement floor. Make it a basement floor. That is good. So check your architectural plan, and first you have to draw columns. Okay. Okay, column arrangement on axis 1 is looks like this. Okay, so a similar column, the architectural plan is similar column arrangements of okay, this, so 14 by 30, that is okay, the big sections of your column is along similar to that of y direction or along y direction. So have to use, okay, have to go to define, go to draw joint. Okay, simply you have to use a shortcut menu. So to draw beam, you have to use this. 4 beams that have not a grid line, but we have fixed all the grid line. So to draw beam, we have to use this by simply clicking on grid lines or by drop down menu. So click delete, and to draw columns, click on this, and you have to, okay, first you have to check your column. You have to put your column section, have to select your column section. So you can draw by simply clicking on grid line or by drop down menu, that is selecting all in this way or in this way. So go to define. Okay, select column. Okay, this. your column arrangement is not correct, so you have to change depth and width from the define menu. So have to go to define menu section, frame section, so columns modify. I have only changed depth and width, that is 550, 350, make it 35 by 55. Okay, so I will show the orientation. So 15 by 35 by 55. So our column arrangement is good. So it's similar with the architectural plan. They're similar with the architectural plan. So you can draw for all and check it further in the analysis, and you can change the cross section. So from basement to second, okay, draw it, and you have to edit it further. I will show how to edit your all your columns. Okay, all the columns are down, so you have to draw basement beam. To draw basement beams, you have to check first the architectural plan. So at this here in this there is open down, that is open down, open down, okay, open down, okay, there is open down here also. There is open down here also. So there is open down here also. There's parking. The ground floor that is up and down here in also. Okay, so okay, the other thing is similar. So up and down is between 3 to 4. Up and down is between 3 to 4. Okay, this part and this part. So to draw your beam, you have to choice, that is by first select your material or your cross section, that is beam 40 by 25. So you have to draw by simply clicking on the grid lines, clicking on the grid lines, or by selecting all this as I have shown before. Okay, between 3 and 4 I have up and down in this area, so I have to pass it. Oh, sorry. This okay, up and down. So have draw all my beams and I have to check the cross section. Okay. It is good to change the color for more the color of beam because it's similar with that of your column. It's good to change, but you can use it as it is. But if it's good to change visualize different colors. So what about okay color of beam? Color of beam is green, but okay. Okay, define frame section. Okay, make it have to delete this. I will draw it again. So, for example, to check the color, okay, use okay. What about this? Define section, frame section. Okay, I will check it by copy on the other floor. Okay. Or okay, the color is not changing. Don't worry about the color. Don't worry. I will further. I will edit it further. So you have to add this. Okay, cancel the extrude one. I will change it further. So the color of your beam. So basement floor looks like this. Basement floor looks like this. You have to a ramp on this. So some beams on the ground floor must be cut. Okay, up and down. So okay. I have a staircase landing beam here, so have to measure the distance. Okay, 150 mm, and the distance from the starting of your beam to axis, that is axis number 3 is that 128 mm, and the length of landing beam, okay, 280. So you have to replicate your beam on axis D to 150. Have to replicate this. Okay, sorry. Select your beam to replicate it 150 mm. So select your beam on axis D that have to be replicated. Go to edit, replicate, or you have to use a shortcut for a replicate. So go to edit, replicate. You can replicate linearly to replicate in x or y direction, that is in x, in negative and positive directions, in all negative and positive direction, to replicate in plan. Or you can replicate this in story also. So have to use linear to replicate in a plan. So to the positive x direction, that is 151 mm. This is because I have to use a metric setting. So make it okay. Your beam is replicated. And also it's better to replicate the beam along accessory to a negative y direction. Select your beam. Okay, what is the distance? 100, 128. So go to edit, replicate, make it negative y direction, 128. So okay, your beam is replicated, and replicate it again to 2.2 to 2.80 or 218 mm to get the bottom, face of your landing beam. So replicate 2.8 meter in the negative y direction. So okay, at this time select this point. Select this point and go to edit to draw. Okay, simply yes, go to edit, add grid lines at selected point. Okay, sorry, add grid lines. Okay, only in the x direction are drawn. Add selected add grid line at selected point in x and y direction. Make it this. You can draw grid lines by putting some angle here from the selected point. Okay, make it okay, don't click here because I have not any angle, so make it okay. And at this time you have you can draw grid lines simply by going to draw grid lines. So you have to draw grids in any direction, but this is the other way of drawing grid. So make it delete your beam. So you have to draw. Okay, click on this. You have to draw your landing beam. Looks like this. That is okay. Beam at the bottom face of, or the bottom face of your landing. So okay, make it same. Okay, what about your shear wall? Measure the dimension. Your wall, your shear wall is 250 by from 196. So I have to draw this wall. Okay, it's 40 mm from the center line, and 182 along negative y direction. So I have to draw this wall starting from axis 4. Okay, you can draw it starting from axis 3 also, but have to choose to start replicate all my data to draw grid lines starting from axis 4. So from axis 4, the wall is 170 mm, and the wall has 182 mm from axis P in the negative direction, and 40 mm in the positive x direction, that is from axis B. Okay, I will draw it. So I have to start from axis 4. Okay, make it relate these two grid lines that I have to use to draw a landing beam. So make it, okay, right click, add or modify grid. So modify. Uh, uh, what about grid line 4? Okay, grid line 4 is that the vertical along the y direction, along the x. But okay, make it relate this first, and I will return back. Make it okay. So what about this? 6. Okay, delete also this grid line. Have the not function after drawing your beam. So right click, make it modify. Okay, delete it. Okay, so have draw a grid starting from axis 4 to draw your wall. So from this 170 mm or 1.7 meter. So you have to get your wall. Okay, make it center. So this is, make it okay, center. Okay, I have to correct my dimension. So 180 meters to the center of year one from axis 4. So I have to replicate. Okay, select your beam, replicate along the positive y direction, that is 180 mm or 1.8 meters. So okay, this is after this it is good to align, it is good to align your wall and beam at the same dimension. So you have to add 4 meter to this dimension, that is 186 mm to this, and make it 10 mm. This is to align both your beam and your wall on the axis to have a similar alignment. So you have to replicate the beam along axis B to negative x direction, that is 186 mm. Yes, 100 to the negative x direction, that is 186 mm or 1.86 meter. I replicate. So have to get Sorry, it's not centered. It's not aligned to the center, so have to make to align to center. Okay, it's half. So sorry. You have to make okay 172 plus 4 mm 176. I have to add 4 mm. I have to add 4 mm. This is because the shear wall is 14 mm from the center lines of from the center line. So you have to shift the shear wall section is 20 mm, so it have a dimension of 10 mm from the center. So you have to shift 4 mm to this direction. So it becomes 176, but the actual measure or the dimension before was 172. So if you add 4 mm, it becomes 176 mm. So delete it and replicate it again. So 176. Okay. And you have to replicate this point or this line to the upward or the positive y direction to get this center line. So 185 mm. Replicate this to 100, 185 mm to the positive y direction. So okay. Okay. So click this point and draw grid along extent y direction. Edit, go to add grid lines at selected point. So click on both y and x and y direction. Make it okay. Grid lines automatically drawn. So have to delete only RBM and you can use the grid lines here. Okay. So you can draw U rule, but at this time I have to tell you something that is in architectural plan. For example, at the basement floor, the architectural plan assumes this all starting from basement to the next floor. That is to basement to ground floor. But when we come to in ETABS, when I draw at basement floor, ETABS assumes it below the basement floor. Below the basement floor. So at this point, the shear wall becomes closed at the four sides, and when I come to the ground floor and when I draw the shear wall on the ground floor, it is below the ground floor. So that means from basement to ground. So I can open it at the ground floor, detail at the ground floor, open detail at the ground floor. But in our case, I have to close in both before direction. So go to you can use both of these two. So okay, at this time you can draw your wall with 200 mm section. Okay, using this or by simply clicking on grid. Uh, go to we make it save. Make it save. You can draw this. Well, okay. So sorry, by simply clicking on the grid. Okay. So ground basement floor looks like this, and copy all this data to the ground floor and make a correction of the ground floor. So select all first, right click on, okay, click on edit menu, replicate in a story. So make, okay, select only the ground floor. If you may click on this, that is delete original object. All things that you have to do on the basement floor is deleted. So you have not need this, so make it okay. So okay, as you have seen from the 3D elevation, all things that you have to do in basement floor is replicated or copied to ground floor. So go to plan, ground floor. Okay, so modify all things here. First you have to modify your shear roll. Okay, your shear roll. There is no a wall along this, it is open. So make it delete. If you see your shear roll, it has opening here in 3D. Okay, this is okay. I will show it. Okay, have you seen? It is opened, so that is good. Make it 3D. Okay, so the other thing is that drawing beam here. Okay, it's good to draw beam here. So first you have to delete grid lines that you have to use to draw a shear roll. Right click here, go to modify grid, modify, okay, delete, okay, make it okay. Okay, grid lines are deleted, that you have to, okay, and draw a grid line to draw beam along this for the staircase. Edit, draw grid at selected point, make it in X direction. Okay, so you have to draw beam and make it delete this, because okay, I have to show this at the back later when we are going to draw reference plane and draw your landing beam, because this all these beams are at landing landing area, so you have to draw beam first. Okay, okay, and make delete this. Make also delete this. because this area is area for a staircase, and have to draw later the staircase. So okay, whole thing is looks like this. There is open down here also. Okay, I'll draw it. And this is open because ramp area or the basement floor. So, and also there is a ramp. There is a ramp here, a ramp and the staircase here. So have to delete this beam and this beam, this beam. Okay, for ramp. Okay, all this beam, and make it measure this dimension 55 mm from axis 5. So this ramp cuts your beam, so it's better to modify this if you put okay, it's good to make it this. So you close this. So 98 meter from axis B. So you have to delete this, or you have to delete this, yeah, and replicate this one to 58 minus 0.58 mm to y direction. This is have measured the okay before. Okay, so make it okay, and 98 meter from this, 98 mm from this, that is 98 in negative x 0.9, that is 0.9, yeah, good. So you have to draw your slab. To draw slab, you can use 3 of this. You have to use this to click at each corner. Okay, how to use this to click, sorry, at each corner. So our slab. Okay, first you have to draw your grid line, reference grid line, or select the point. Okay, what about this? Can delete. Okay, slab 150. Okay, so make it this. Have modified the architectural plan around this because it changes loading transfer mechanism, so it's better to close this area or make it a slab. And you can modify the ramp. You can modify the ramp. Okay, we have a long area to put a ramp from this to this, from to this to this. So have to draw the slab like this, and to draw this slab, that means this slab, you can simply use this sorry this is okay. You can simply use this and click on this. Automatically our slab is drawn. So to draw this, okay, if you click this, it draw by keeping inside the grid line, and you can join this merge by selecting the two slab, say merge slab, or you can draw using this by clicking all the points. Okay, this is open. Okay, so back to this. This is open area, so this is our staircase area. So have to draw this. Okay, have to draw like this. Clicking by simply clicking on the points. Okay, and this is a staircase area, so you can draw around this. The slab around this. Okay, this is opened here and here also. So okay, this is area of stair. Have to back ladder to draw the staircase. So between 3 and 2, between axis 3 and 2, between axis 3 and 2. Okay, so first you have to delete reference grid lines. Make it delete. This is also a reference grid line. Make it okay. So you can draw slab by selecting this and simply clicking. Okay, and also okay, this you can check the architectural plan. This okay, but at this time I have open down here. That is 1.84 mm from the center line, and make it add 10 mm, where that becomes 1.94 mm to get the center of your beam, and make it from the center. Okay, you can add 10 mm, not 10 mm. Our beam is 25 centimeter width, so 12.5 centimeter or 125 mm, 12.5 millimeters, I mean. So you can add 12.5 mm from this and 12.5 mm from this. So make it 12.5. Make it like this first. Replicate it 12.5 mm. So have to measure. Okay. Okay. From center to center, it is 19.6 to the positive x direction and 12.5. Okay. 3.78 meter from axis to, so have to draw up and down. We have draw up and down in many other choices. You can draw in many different choices, so it's simple to draw like this. So first I have to draw beam along this direction and this direction. So I have to replicate starting from axis 2 to 3.78 along positive y, 3.78 meter along positive y direction. So I replicate 3.78 along positive y direction. So the beam is drawn as a reference line. So from axis A, 196 mm, make it 196 mm to the positive x direction. So have to have to draw a reference plane at this point and at this point. So have to delete this beam. It's not necessary to extend this beam to this direction. So to draw this, have to click on beam. So make it. Oh, sorry. There is no reference plane along this. So it extends this up to this. Sorry. So you have to draw beam 14 by 25 and select this. So you can draw your slab here. Join these two slab. This is about ground floor. You have to replicate this. Okay. First you have to replicate this and you can edit to the other floor. So this beam is okay. It's good to extend up to this because the dimension of this up to this is beyond 2 meters. So have to check that. Two point 0.35. So long. So it's better to extend this beam up to this. Okay, you can copy all this and use it to first floor, replicate to first, and you can edit. Okay, automatically it's replicated to second floor, and you have go to second, the first floor. I mean, it's replicated to first floor, and you can edit it further. So go to first floor. This is at ground floor. It's a slab. So in second floor, it is open. Okay, it's open up to this. Okay, this up to this. Have up and down, starting from here to here. Starting from to here. So and a wall that pass through this. So and there is a wall that passes through this. Okay. And this up and down at the ground floor is also closed. Okay. Okay. There is some change around this. Okay. First floor looks like this, and there is up and down here. Up and down here. Up and down here. Okay, this is the change between ground to first floor. So have to edit the ground floor that have to replicate to first floor. So I am in the first floor, so there is up and down around this. So make it delete this. So first you have to delete the grid line, reference grid lines. I mean that. Make it delete. Make it delete. Make it okay. So the slab around this. First, the slab around this. It's full slab. So make it delete all this also, and make it a full slab. Make it a full slab. That is okay. And there is up and down around this. So the up and down from the center of your column, that is from axis 1 let us say this dimension and okay, draw that line and replicate it to the center 12.5 mm. So how to measure up to this line. Okay. So you have to get it up to center 192 mm from axis 1, and from axis C there is a wall and a beam passing through here. From axis C from axis C to at this point the wall is 2.65 and make it up to center because we have a beam around this. So draw a line, make it replicate to 12.15 mm. So from the center lines of this beam to center lines of axis C, it's 2.78. And replicate this dimension to the next one. So have to measure analysis. I think these up and downs are similar. If it is okay, they are similar actually. So have to use similar dimension starting from axis. You have to first draw test beam, that is 1.92 meter from axis 1. So have to draw this, replicate 1.92 to the negative y direction, 1.92 meter to the positive y direction. So this is, and I have to replicate this beam to positive and negative x direction respectively by 2.78 meter. Make it replicate 2.78. I have to check it. 2.78 meter. 2.78 meter to the positive y direction and 2.7 meter to the positive, the negative and positive x direction respectively. So have to draw a reference grid line along this point. So we have to okay, you can delete this beam, make it as it is this beam, make it as it is this beam, and join all the frames because it as it acts as one beam, make it join frame. Okay, so it acts as one beam. So you can delete this because it's up and down around this. So I have to draw beam to this and this. So first I have to draw a slab to get up and down. So by simply slab 160, clicking on this. So the up and down area is this, and you have to draw our slab by clicking here. So here and here, one slab, and sorry, you must click at the joint to not overlap with the other structural elements. So the up and down looks like this, but I have to check the dimension of this slab. That if that are greater than 2 meter, have to add beam or column. So to know the cantilever length of this, you have to divide it, this dimension into 3. If it is greater than L over 3 of this dimension, or 4.4 meter over 3, you have to modify it, or if and that is better to check with 2 meter, that is a maximum length of cantilever recommended in Ethiopian building code of standard. So have to measure this cantilever length and this. So this is 2.65, that's greater than 2 meter. And what about this? This is 1.9 around 2 meter. Okay, make it as it is, and have to draw a beam around this to transfer loads exactly and make it join these two beams as act as a one beam. Make it okay. It's better to extend this beam up to this. So because it's a large dimension, so have to it's better to extend the beam up to this to make to be safe. Okay, so this can act as a cantilever. So uh, okay, so you have to draw slab sections between 1 and 2. You can proceed between 2 and 3 by first you have to delete a reference grid line because I have finished drawing that last, so make it okay. So between 2 and 3, check your architectural plan between 2 and 3. Okay, there is no up and down. Make it as it is, and between 3 and 4, between 3 and 4, there is a modification here only, that is the slab extends up to this, so have to extend slab by drawing a reference grid line along y direction at this point. So have to draw using this, click here, here and here, and by clicking here, here and here, that is good. So between 4 and 5, make it relate first a reference plane, a reference grid line that I have to draw. So make it okay. Between 4 and 5, there is also the reference plane. Make it relate. That's it. Okay, have to save it. So between 4 and 5, between 4 and 5, there is up and down around this and this, and the other slab are as it is. So have to delete this. Have to delete this slab and have to draw all the beams because all the beams are there in the first floor plan that are opened to ground floor plan for ramp purpose. So first you have to draw the beam. Have to draw beams. Okay, so before drawing slabs between axis 4 and 5 here in this area, you can draw beams between 5 and 6 because there is no up and down around this, so you can draw all the slab here. Okay, so this is also full slab, but you have up and down around this and this. Have to draw it. First you have to extend up to the center line because it needs beam around this. So measure it up to center. Where's the center line? Up to center line, and center line around this is this, that coming on axis A. So you have to extrude the beam from axis A to the center of the second beam to 1.96 meter. Have to 1.96 meter to the positive x direction. So up and down is around this. So you have to extend also, starting from axis 4 or 5. You have to replicate this line or this line to get the up and down area. So it's better to use axis 5. From axis 5, it has a dimension of, starting from the center of axis vertices to the center, because it needs a beam so greater than 2 meters. So have to replicate it to get the center line. So okay, so the up and down measure is 2.82 meter from axis 5. So 2.82 meter to the positive y direction, 82 meters, and cancel that. 2.82 meter to the positive y direction, make it okay. So the up and down is area this. Have to draw. I can't draw my slab by putting a reference grid line at this point, so can delete it. Okay, sorry, I have not draw reference. Make it and also I have not draw reference grid on x direction. Okay, so you can draw our slab by simply clicking at the corner points. Sorry, by simply clicking at the corner points. Okay, this is so. Have to proceed to the next. This grid line, I think it's the up and down is aligned to this. It's around this. I have to check it. So okay, have to proceed the center line. Okay, center line. Yes. So the only difference is that have to check this only. Make it center. That is 12.5 mm. Okay, 200 0.3 to the negative y direction. 200 0.3 mm to the positive x direction. The negative x direction, 2.83. 2.803. Okay. Make it this is the area of open down. Make it draw a reference grid. So I have to a chance to draw your slab here by clicking at the corner point. Yeah. So at this time, it's better to modify. It's better to modify. Okay, make it cancel the spin. and you have to draw beam around this. Okay, cancel this one because beam and slab are overlapping here. So when you analyze your model, uh, before analyze your model, have to check the model. So when you check it, the ETABS automatically says your beam is overlap. Your beam and slab is overlapping here. So make it delete and draw it again. So have to draw this. Okay, and have to uh, make it doing this. So it's better to draw like this. So have to finish drawing of first floor and have to proceed to proceed to typical floor that is second to fifth. All things are similar here in second to fifth, but the only thing is that there is up and down here and here, and also a cantilever slab around this that is 1.22 meter from axis 6. So okay, I will show how to. I will show all things that have drawn. So we have to proceed in the next part, that is part 3. It's better to stop here. It's better to stop here. In the second video, that is part 3, we have to start by drawing second to fifth typical floor and the terrace water tanker, and also drawing of reference plane and drawing of staircase. Thank you. Subscribe my channel to get more videos about structural design of any project. Thank you.